Okay, so this is different ways to write domains, okay? On your left is interval notation. On your right is set notation. Okay, in the middle is the words. So on the first one, it says all real numbers that are greater than or equal to 3 and less than equal to 4. So 3 is your smallest, yes?
Yes.
4 is your largest.
Yes.
And it's equal to, so we put brackets for interval. Okay? So for set, x such that 3 is your smallest, 4 is your biggest, and you just put your inequalities in there. Make sense?
Yeah.
Okay, so all real numbers that are greater than 3 and less than equal to 4. So greater than 3 would put a parenthesis right here. And a bracket because it's equal to. So when I come over here, it's going to be exactly the same with x such that 3 is less than x, which is less than equal to 4. I like the set notation because the words changed into a symbol, did they not?
Yes.
3 is, all real numbers that are greater than 3, so that would make 3 less than x, which is also less than equal to 4. So the next one, all real numbers greater than 3, less than 4. So both of them are not equal, so I have parentheses. And then what am I missing over here then? Oh, wait. Greater than equal to 3. So it switched places. Is it making sense what I'm talking about here? Okay, I'm not going to read through all of them, but I am going to show you all real numbers greater than equal to 3. So 3 is my smallest, and everything greater, where's the last greater number?
Infinity.
Positive infinity, right? Now, they don't put it, but I usually put positive infinities because if negative gets a sign, why shouldn't positive, right? Just be fair. When I point that way, I'm pointing towards what?
Negative.
Negative infinity. When I point that way, I'm pointing towards positive infinity. I do it all the time. This chart is in your book. If you would like to write it down, go to your book and write it down. Spend the time to go through it and pick through it. Got it? Questions about it? Okay. I'm hoping I turn around and it just goes poof, big. Okay, what is the domain and range of the function of this? So remember, domain are what values? What kind of values? X's or Y's?
Wait, you go back.
What?
Is there do they put the brackets and things on the set notation? Are they?
On set notation of the curly brackets, I know it's kind of hard to see. They're the curly where you go. Okay, I draw them. Watch how I draw them. I go from top to middle, bottom to middle. I don't do the whole thing at one time. Then they look weird. Okay? They don't look very great with this yet. I'm going to be an expert soon, I think. Hopefully. Okay, so domain and range. Domain are what values?
X.
X. Domain are X's. What are range? Y. So when you look at a graph, you're really looking at all the Y's, kind of, aren't you? Like you're looking at the points, but the Y's really show up. So domain, we look at a function and say domain. What can't go in the function? That's really what we want to know because really most functions, it's all real numbers unless it's a fraction or a square root or like a logarithm or exponential. Like for most part, it's all real numbers. But is there any restrictions to what I could put into negative x squared plus 3? No. And what I mean restrictions is, can I divide by 0? Can I divide by 0? No. So if I had a rational function with an x in the denominator and 0 was there, then I can't do it, right? What about a square root? Can I take a square root of a negative number? No.
Yeah, we haven't learned that.
Well, you haven't learned it, but it's not real. Anyway, you can't graph it. So that doesn't work. So is there anything that wouldn't work in this problem? No. So the domain would be all real numbers. So you just write D. You don't have to put domain. Okay. And the equation is right here. You can sketch the quick, whatever. You have to learn what you need for notes. These notes aren't for me. They're for you. Okay, so D, and we said it was all real numbers because there's no restrictions in what I can put in there.
So then you
So I'm going to do it set notation first. So the set of x's such that x is a set of real numbers. It's a double backed R. That's all it is. It's a little bit better writing than yesterday. Okay? For all real numbers, set notation, it's really easy. X such that. Remember this line right here means such that, doesn't it?
Yeah.
Okay.
We have a range to it.
Yep, we'll do range too. Now, in set notation, all real numbers, that means negative infinity to positive infinity. Can I get to either one of those things?
No.
No. So I'm not going to use brackets. I'm going to use what?
parentheses.
Parentheses. So it's parentheses, negative infinity, comma, positive infinity, parenthesis. And this is just all real numbers. We don't write the words out, all real numbers. We use symbols now.
So is this
We're
for
big
range?
kids. No, this is still domain. I have not put an R up there anywhere except for real
I
numbers.
thought it,
Okay. I have, what kind of notation is this right here?
Set notation.
Set, and this is what?
And, oh,
Interval.
yeah.
Yep. Okay, now, Carly, we're going to do range.
don't ask me what it is.
Wait,
Okay.
did you-
Not now.
Wait, what's the back door again? Real numbers?
Yes, real numbers. Real numbers, double backed R is just the universal symbol for real numbers. A double I is integers. Okay, so now we need the range. Range is much easier when you look at a graph until you really get to know them. By the time you get to pre-calc and calculus, you should be able to kind of see them in your brain. We're going to spend a lot of time this year graphing quadratics. This is a quadratic, it's a parabola. And we're going to learn that when you see this in about a month, you're going to say, oh, it opens down and 0, 0 moves to 0, 3. So 0, 0 went to 0, 3 and it opened down. You're going to see that and know what it's going to do. Right now you don't, okay? So you're going to look at the picture. So what's the smallest y?
3.
What's the smallest y?
Negative.
Negative infinity. And I know it's negative infinity because there's little arrows on the end of here, right?
Yes.
Okay, so my smallest y is negative infinity. What's my biggest y?
3.
3. So it's all y's less than what? What's
3.
not negative 3?
3.
3. All y's less than 3, yes? Okay, so in set notation, we're going to have the set
So do we
of
always-
y's such that y is less than, can it be equal to 3? Yep. Equal to 3.
Do we always have to have them for like each pair? Like, say for range, do we always have to have set, builder notation, and interval?
No, you can have either or, but I want you to be able to read both.
So are we
Okay.
putting both right now?
Yes. Okay, so in interval notation, what's the smallest?
3.
No.
Nope, it's negative.
Negative infinity. Is it included?
Yeah.
Negative infinity is included. You can get there. Can you get to negative infinity?
Not included.
Not included. So it's a what? Parenthesis. Comma. And what's the max?
3.
3.
Bracket.
Bracket. Because I can get there, can't I? I still have people in pre-calc that are doing their domains in interval notation, and that's perfectly fine. I am never going to force you to do them in set notation, but don't ask me what my set notation means, because you should be able to read it, correct? Okay,
Yes.
but you can for a while, but later on, don't ask.
That's confusing.
Okay, so now we have this really big picture, and it shouldn't be that big, because now we have hardly any room to write, but that's okay. So you need just the equation. Don't write the whole words down. You see the equation on there?
Yes.
Y equals. I would highlight it, but the highlighter doesn't really highlight. Like it erases it. Look at this.
What?
That's the highlighter. To me, it doesn't really highlight.
Just underline
Well, it's okay. So y equals 16 minus 0.05x. So let's read this. It says a car starts a journey with a full tank of gas. The equation is y equals 16 minus 0.05x. Relates the number of gallons of gas, y, left in the tank, and the number of miles it's traveled. What are the x and y intercepts of the graph? And what do they represent about the situation? So you're examining. Yes, Angela.
I can tell you what the y-intercept is.
Okay, so what's the y-intercept?
The y-intercept is 16.
16. The y-intercept is 16. Does everyone see that?
Yes.
Okay, what does that tell me about this?
It's how much gas we started with.
It's how much gas we've started.
I'm so confused. So the D.
Okay, can you raise your hand ever, please?
No.
Okay, Carly, you need to start raising your hand. Because sometimes you need to let me finish before you start talking. Okay?
Okay.
Okay, what is your question, Carly?
It's fine.
No, Carly, I'm not trying to stop you from asking a question. I'm trying to get you to wait a second and wait for me to be ready to call on you.
No, I got it now.
Are you sure?
Mr. Meyer on her. You get an angry this week.
Carly, what are you confused about?
Nothing.
You're
I'm
lying.
confused about everything.
No, you're not. I just wanted you to take a second.
No.
Okay. A y-intercept is where this graph hits what?
The starting point.
The y-axis. Yes?
Yes.
And it is at 16.
Yes.
So that means and if you read the scale, it says gallons of gas remaining gallons in gallons, right? Okay. So it means I start with 16 gallons, and how far have I gone?
0.
0. That is the y-intercept. So Carly, what is my x-intercept?
I can't even read that. So 320.
320. Good job. So 320 is my x-intercept. What does that mean that I've done?
You went 320 miles.
320 miles on 16 gallons of gas because I have how much left now?
0.
0. Can I ask you 80?
Yeah. I guess
Okay,
so.
80 miles, how much gas do I have?
12.
12. Okay. At 240, how much gas do I have left?
4.
4. You're pushing it if you only have 4 gallons of gas and you're going to try to go 80 more miles. Okay. So they are on the side of the road with no gas. Yes? Okay. So does this make sense?
Yes.
Okay. So I want us to look at the equation now. You wrote the equation down on your paper. Y equals 16 minus 0.05x. What does 16 represent in that equation?
Y-intercept.
Okay, so the 16 in this equation is telling me how many gallons of gas I started with. Yes?
Yes.
Okay, otherwise known as the y-intercept. In this equation, this negative, why is it negative?
Because you're at 0. Wait, what?
It's
That's
going
not
down.
negative.
Yeah, it is.
Because it's declining.
Because it's declining. What's declining?
The gallon.
The gallons of gas. I'm moving down the road, right? Okay. What does 0.05 tell me in this equation?
How much gas are you using?
How much gas I'm using per mile. It's my rate of change, isn't it? Otherwise known as my
Rate of exchange.
slope. Yes?
I hate that word.
Y equals mx plus b. Yes?
Wait, what?
Y equals mx plus b?
She sure doesn't do this.
I did. Okay. 0.05 is my coefficient of x, so it is my slope. I am using 0.05 gallons of gas per mile. Yes?
Wait, the other question I was trying to figure out.
We already did it. What does the x and y intercept?
What are you got me doing now, Miss Smith?
Lots of stuff. Okay. So I got you to analyze it without overthinking it. So now when I ask you for the zeros of a function, x-intercept are also known as zeros of the function. You need to write that down. X-intercepts are also known as the zeros of the function. They are also known as solutions. I'm putting it back. I'm chill. Also, what did I just say? Solutions? Okay. So, x-intercept, zeros, and solutions. When I ask you to find any of those things, are they any different?
No.
Nope. The only difference is how you write them. The only difference is how you state your answer. An x-intercept, it should be an x value, comma, 0. Because what is the y value at any x-intercept? 0. A 0 or solution you can just put x equals. You do everything the same. Its only difference is how you write your answer. Okay? So, what's another word for a 0?
Solution.
Solution. And?
Function.
Nope.
The X
X.
X.
What? X what?
equals.
Nope. X-intercept. So you have x-intercept, 0, and solution. I will usually just write x int for x-intercept. Because I don't want to write intercept every time. You do want to write it every time?
Yeah.
No. Okay. What is the x and y intercept? Ooh, that was fun. Oh, look at that. That's just with my finger.
Maybe you write better with your finger.
Probably not.
Erase it all.
But then I'm going
Miss the
y.
spot.
Okay, so find the x and y intercept. So remember, I'm just going to draw a picture to remind you. We're going to start with the x-intercept, and we're always going to label our work. Always. Okay? So x-intercept. X-intercept of y equals the absolute value of -3. So x-intercept happens like right here. We're just going to like right here. What's the y value there? 0. So what I do is take the equation and plug 0 in for y. And solve it. So how would I solve that equation? For x, obviously. It's the only variable. I would add 3 to both sides. So 3 equals the absolute value of x. Now, here's a question for you. If I took the absolute value of a number and got 3, I actually have 2 options of what came out of there. -3 or 3. So x equals -3 and 3. But that's not how we write an x-intercept, is it?
No.
How do we write an x-intercept? The x value, comma 0, and the x value, comma 0. Because an x-intercept is a point on a graph, and we always write a point as a point, don't we? Okay, so over here, I already made a line, so I'm just going to make 2 more. I'm just sketching. It doesn't tell me to sketch this. I'm just doing it, okay? So if you don't want to put it, you don't have to. So I'm going to change my color over here.
How do you get 33? Never mind.
No, I don't have a 3 or -3. Are you good now? I mean, I know it's kind of small right now.
No,
for
I'm
some
still
reason.
confused. How'd you get from that one to the bottom?
You
thing?
add 3 to both sides.
You add 3 to
I got
both
that
sides.
part.
Okay, so in an absolute value, Cole, what is the absolute value of -3?
I don't know.
3.
3.
The obstacle.
Oh.
Okay, what is the absolute value of 3? 3. No, 3. Absolute value is distance. How far is -3 away from 0? 3 units. How far is 3 away from 0? 3 units.
Okay.
Okay, so in here could be a positive or -3. Okay, so here's my x-intercepts. Now I need to get my y-intercept. So on the y-axis, what is the x every single time, no matter what equation? 0. So I put a 0 in for x. So y equals the absolute value of 0 minus 3. Well, what's the absolute value of 0? 0. So y equals what?
0 minus 3.
Just negative 3?
Yeah.
So how do I write that intercept then? What did I plug in for x? 0, comma, negative 3. So I'm going to come over here. Now, this is the other thing that you probably don't know quite yet, but you will know soon. Absolute values have a distinct shape. They are a V because you can't ever have negative values happen. So, well, inside of them. So what this is we're taking the absolute value shape and we're moving it down 3. That's what this equation tells us. And like I said, in about a month, you'll know that. And so this is the shape of an absolute value. And if you want to write that off to the side so you remember it or something, you can. I will review it. That's what it looks like. And you just found the x and y intercepts. But it didn't ask me to graph it, did it?
No.
Nope, it just said ask me for the x and y intercepts, didn't it? Now, I'm going to tell you right now, pre-calc has already done this week. Calculus just did it yesterday and today. Finding the x-intercepts, stating the domain and domains, doing all that stuff. This stuff doesn't go away. So the sooner you try to grasp it, will it make everything a little bit easier?
Yes.
Yes. Okay, questions before we move on to the next one. How did I get something? What did I do? What, Kyson? Are you done writing?
No, not yet.
Okay.
I just don't get it.
I don't get any of it.
Same.
Because you're smart, bro.
You just go with the flow.
Yeah, that's what I'm doing.
I would appreciate not the negative comments. It would be helpful for everybody, especially yourselves. Are you done, Kyson?
Yeah.
Okay, if you have a specific question, I'd be happy to answer it. So please ask it. Okay, so 3. You are going to be asked to identify intervals. So when I'm asked to identify intervals, I probably am going to write it in what notation?
Site notation.
No,
Interval.
interval notation. Okay, when you're asked to write find intervals, you're going to be writing things in interval notation. That's what you're going to do. This is one of the reasons why I don't do domain and intervals. So it wants to know when this is positive and this is negative. So when something is positive, you're talking about the y. So above the x-axis is positive. Yes? Below the x-axis is what?
Negative.
Negative. So it wants to know where this graph is positive and where this graph is negative. That's it. So you're going to write on your paper positive, and you're just going to put POS, and you're going to write negative. Okay? You're going to write it. And then you're going to look at the graph, and you're going to move from left to right, because that's how we do all graphs, left to right. So is this graph positive or negative on the left? All the way to negative infinity. Is it positive or negative?
Negative.
Can't even see.
Is it above the x-axis or below the x-axis?
Positive.
It's positive. I didn't say going negative. Like it's going negative, yes? But it actually is positive. Like its position is positive. So, from negative infinity to what is it positive? Where's it change from positive to negative?
-3.
Negative 3. So can I ever be negative infinity?
No.
Nope. So I write parenthesis negative infinity. And I just wrote an 8. That was nifty.
Write an 8 sideways.
Okay.
Where did 8 come from?
I just wrote an 8. Okay. So right here, it is changing from positive to negative, right?
Yeah.
So we can't include that point because it's basically 0 right there, isn't it? But that's negative 3, so it's not included. So we also put a what?
Thing,
A parenthesis. Okay? So now we're going to pick up. At negative 3, it's going to now change into what? Positive or negative?
thing
Negative because it's where? Where's it at?
below
below the x-axis. So we're going to come to the negative and put parenthesis -3, comma. And it could be to negative infinity, right? But it's not. It comes back up to where? Where it's right here. 3. And 3 is not included because, again, 3 is 0 in this case, correct?
What are you getting the second 3 at?
Right here.
Oh.
See, intercepts. The x-intercept is where these things happen at. Okay? Now, what's over here? Is it positive or negative?
Where?
Is this above the x-axis or below the x-axis? Above. So it's going to go here. So we put this symbol right here. It's a U. It means and. You have to put that symbol there. Because it's this interval and what? Where's this next one start at? 3 to what? Infinity. So 3 comma positive infinity, and every single one of these is with a parentheses because the point can't be positive and negative, can it? No. Now, again, what does positive mean? It means the graph is where? Above the x-axis. So these are my positives, yes?
Yes.
Okay, and my negatives are below. So my negative is down here. Do you notice how I went from left to right?
No.
I went negative infinity to -3, -3 to 3, 3 to positive infinity. Is there any gaps?
No.
Nope, there should not be any gaps. So let's do another one. Okay, where is it positive, where is it negative? It's showing you the equation just so you can see it. All this up here is what? Is it positive or negative?
Positive.
It's positive. Why is it positive?
It's above the x-axis.
It's above the x-axis. I didn't turn on my pen. So all this up here is positive. Both these pieces down here are what?
Negative.
Negative. What point? Where's my changing point? Right here and right here. And I think that's 5, 10, 15, 20. So 5 and what?
-5.
-5. So what's clear over here?
Where are you getting
Infinity.
Negative infinity.
The intersection.
Because this is 20. I got a lot of trash on there, don't I? The scale's 20.
So is this kind of like factoring?
It kind of. It will lead us to further factoring. Zeros. When you factor, you're finding the zeros. So yeah. So this scale is 20. So that means this is 5 and this is -5. Okay? So this is negative infinity. This is what over here? Positive infinity. So I'm going to show you. Here's my intervals. Look here. Interval, interval, interval.
Nice.
Do you see it?
Yeah.
Does that help you see those intervals? Let me do it again. Because when we went across the last slide, we went from left to right. We're going to do it from left to right. So I'm going to write positive and what on my paper? Positive and negative. I'm going to go left to right. I'm going to start at negative infinity. Is this graph furthest to the left, is it positive above the x-axis or negative below the x-axis? Further over here, is it above the x-axis or below the x-axis?
No, it's below.
It's below. From the left. You're coming from the left, like you're walking down the street. Like this.
Oh.
Okay? Is it above the x-axis or below the x-axis first?
Negative.
It's negative. So negative infinity to what?
-5.
No. Negative infinity to what?
No.
To -5. At -5 is where it goes to positive. Okay, so then at -5 I jump up to where? Positive. And then I keep walking to where?
Positive.
Positive 5. And then it jumps down where? Well, it goes negative, right? So we put a union, a little u, and negative infinity to not, shoot. No, it's not negative. It's not. I was saying negative infinity, and I wrote a negative. So it's 5, just a second, Carly, to negative infinity. So it started at, how about positive infinity? I started at negative infinity and I'm ending where? Positive infinity.
That makes sense.
Everyone starts at negative and ends at where?
Oh,
Positive. Carly, what is your question now?
Well, like, I looked at the homework last
Mhm.
night, and this looks nothing like it.
It tells you where is intervals positive and negative, and then the next thing it asks you is increasing and decreasing. And that's where we're right now. Okay, increasing means every graph starts what direction? What direction?
Left.
Left. It ends going what?
Right.
Right. Increasing means the graph is going what? Up. Decreasing means the graph is going down. So this one wants intervals of increasing and decreasing. Okay? So decreasing means it's going what?
Down.
Down. Oh, I'm going to go back. Okay? Down. Increasing means it goes up. Decreasing means, I cannot do this today. Decreasing means goes what? Down. Okay. So, looking at this graph, you see it's an absolute value. They drew it for you. They're always going to give you the equation just so you can start seeing what's going on. Okay? So, we're going to go in, and I write in, and I write D. Actually, I usually go INCR and DECR. Okay? Increasing, decreasing. So, left to right. Is it increasing or decreasing from left to right? It's increasing, isn't it?
It's going up. And
It's going up because you're going from the left. You start from the left and it's going what? Up. So from negative infinity to where?
The two.
To x's. X. What's my x? What's my x? What is my x right here?
Oh.
Right where the blue dot is? 0. Okay?
Say 0, but
I'm sorry, guys. I can't do anything right. Right here is 0. Yes?
Yeah.
Okay? So, to 0. At 0, you're looking at y's. When we talk about things, we're talking about x's. Always the x's. Now, what's it doing? Decreasing. And you got to go from 0, right? To when?
Wait, why did it go from 0?
At 0 to positive infinity. Because 0 to positive infinity on your x's, what are your y's doing? Okay. As my x, let me get a different color maybe. As my x's go out to positive infinity, what are my y's doing? Decreasing. Now does that make sense?
yes.
Okay, so from 0 to positive infinity, it is what? Decreasing. These values are x values, not y values. I'm talking about the x. This is the y values. Does that help?
No.
The increasing, decreasing are the y's. The increasing and decreasing are the y's. The negative infinity to 0 are my x's.
Students have messages in the office.
So
Alex Seaman.
so when I go this
Joe
way,
March,
this is negative infinity, yes?
Yeah.
Yes.
So I started here, and then it's going up,
Alex
yes?
Donovan.
Okay, so negative infinity to 0 going up. From 0
There's an FF meeting.
To positive infinity, it's going where?
IAP,
down.
room 108.
Wait, why?
Be sure you report to your IAP first. and
Okay,
then
I think you're
report
just kind of overthinking it. Let's do one more.
to tough policy.
Oh, that's rate of change. Okay, we still didn't get through there. So
Okay,
we only had one. Okay, what is rate of change, guys? I'm going to go back. What is rate of change?
and there
Doesn't have
It's
no-
slow.
Jim
Isn't it like X and Y in the box?
today.
No, rate of change is slow.
No open.
Rate of change is slow. So if I want the rate of change between, I know this picture is little, from this point to this point, I do the slope. What is the slope function? Y.
Y2 minus Y1.
Nope, let me go back. Okay, y2 minus y1 over x2 minus x1 equals slope, which also equals rate of change, or average rate of change, okay?
Are we good for our homework now?
Yes, you are good. One thing I want to show you is remember that chart? I said if you want it, go to your book and fill it out. At the end of every section, there is something like this, and they had it in your geometry, and they're going to have it in here also, but you might want to go and look at it. After everything you've done, this might be something that you take a look at. Actually, wait a second. Nope. Okay. Scratch that. I'm going to add this to your homework. I want this in your notes tomorrow so we can go over it. I want this chart in your notes.
All that?
No, don't, Connor, it's better out of your book.
No, I know, just so
Okay.
I even know what.
Okay,
Yeah,
I
I
want this chart. It says concept summary. It's on the video. It will be there. You can freeze it. You're not going to have a really good picture, guys. Sorry.
No, I just
So,
have the picture
I
so
know,
can.
but you need to watch the video, look in your book. I want this in your notes. So tomorrow when I'm talking about it, you're not trying to write. Because what happens when you're trying to write and I'm
You
talking?
don't listen.
You don't
You
listen.
don't listen.
You're just copying down garbage, right? So I want that in your notes. All of your homework should be good. This is added information that we're going to move further. Have we done an absolute value today?
No.
Have you? Yes.
Oh, yeah.
Have you seen a parabola today?
Yes.
Have you seen a linear? Yes. Actually, that was the one you haven't seen today, but you should know everything about it. Oh, no, car, gas was linear. Okay.
Oh, yeah.
So those are graphs we're going to learn to move around. These are the basics. We will discuss them tomorrow. Got it?
Constant.
What? What about what? Oh, the constant one. Yes. Sorry. I'm like, what? Okay, so you have, and I'm going to tell you, you have 2 assignments. And I want you to do them. I want 10. I want Tuesdays and Wednesdays to be attempted tonight. Because some of these should be very quick. Some of them should not be very quick. We will go over questions and you will have time to work, but I want you to come in with both of them with something on them. Got me?
Don't forget.
Hopefully you finish them both in class tomorrow and have no homework. That's the hope.